All right, let's take a look at lesson 3.3. The first thing I've done is I've opened up our pre-programmed graphs. Remember, there's a shortcut way of doing this. If you go through Clever, you can just click on my page and you will see the pre-programmed graphs link right in there. Or you could open up PowerSchool Learning, go to lesson 3.3 and click that right from there. But either way, open this up. What I want you to do in the future, I might have number 3 ready to go. I started adding one, but it's just not ready. What I want you to do is open up a blank graph, just a blank graph. Anytime for domain and discontinuities, there are 3 rules that we've learned to describe where a break in the domain will occur, which means a discontinuity. The first has to do with division, second has to do with square roots, third has to do with logarithms. What are you not allowed to divide by? 0. Good. There's one rule that says you cannot divide by 0, which there's not a does not equal, so I'll just put equals 0 there. There's a second rule about square roots. What's going to be true about a square root? Can't be negative. That means it can be greater than 0. It could be equal to 0, but it can't be negative. That's your second rule. The third rule has to do with logarithms. What have we learned about a logarithm? It can't be negative, also can't be 0. So this one has to be greater than 0. Those are the 3 rules. On this particular problem, what do you happen to see is included in the equation? Division. So here's what I want you to do. And I'm not going to give away the answer. I'm going to let you try it on your own. I want you first to type in the exact equation. F of x equals x squared minus. Pardon me? No. I was just showing you the rules. There's your rules. X squared over 9 divided by x minus 3. If you watch the video later, I'll probably have a calculator number 3 that will demonstrate this for you, but it's just not ready yet. So there's my graph. Now what I want you to do is ask yourself the question, what are you not allowed to divide by? 0. So copy the denominator and say the denominator cannot, or since there's not a cannot equal, just do equals 0. So I took the denominator equals 0. This purple graph will break at the black line. That purple graph breaks at the black line. I know this because it's not allowed to equal 0, and that's where it would equal 0. What I want you to do is click on the purple line, because that's what we care about, is the f of x function, which yours might be a different color, or whatever color. You click on the f of x function and see what happens when I'm clicking and holding on my mouse. Drag it to where it overlaps and see what happens to this symbol. Okay, I'm going to give you a moment to try that on your own. All right, so now that I walked the room, here's what I wanted you to, what almost everybody has shown me, is that when you click and drag like this and you overlap, what should the picture do? Not only say undefined, that is true. It also does something else to the image. What happens to my image? It has that open circle. So what type of discontinuity has an open circle like that? Removable. So just on your packet, what I'd recommend, since you can't submit your answers just yet, is to go ahead and draw it like that. So later you can come back and remember what the graph looked like. What you would say is that's at x equals 3. At x equals 3, it was undefined, which you said it's undefined because it was a, what type of break again? A removable discontinuity. Removable discontinuity. And that would be the answer to number 1. All right, the second problem on your bell ringer said the Richter scale is used to calculate the intensity of an earthquake based on the amount of observed motion. An earthquake's Richter scale measurement is calculated using that formula, where A is the amplitude of observed motion in micrometers. What is the amplitude A of an earthquake that measures 6.15 on the Richter scale? First question I have for you is, what am I trying to find? What am I looking for? The amplitude. That is going to be like my X value that I'm looking for. Amplitude is X. Or it says A, but I'm going to plug in the X there. That's what I'm looking for. They gave me the number 6.15. Where can I put 6.15? Very good. Into the R, because that's the Richter scale, which is the R. So this problem, if I substitute in, I have 6.15 equals 3.75 plus the log of, instead of a, since I'm looking for it in a calculator, I'm going to use x. Desmos just works better if you use your variable as x. So there it is. We need to solve this problem. And if you want to use a calculator, I do have a calculator that will solve. I'm going to close this one. It's because I'm solving for a variable now. Which calculator should we use to solve something? InSolve. Very good. Number one. So go ahead and open up number one. What I'm going to do is read off this first block. Here's your first instruction. It says to InSolve an equation. First type the entire equation in the line below shown in red. So this here's the red. We need to type the whole equation in right there. So what do I mean by the whole equation? Everything as in what? Thank you, Lyric. 6.15 equals 3.75 plus log x. So you type that in first. After you type that in, this says, secondly, graph y equals the left side of equation. And I added a little parentheses to make sure you understand what I mean. The left of the equal sign. And y equals the right side of equation, which means the right side of the equal sign. So what is on the left side of my equal sign? 6.15, 6.15. So this says graph y equals the left side. So y equals, just remove that x and put 6.15. Then it says graph y equals the right side, which means the right of the equal sign. So I'm just going to copy this. You can highlight it. Hold down Shift, press C, that'll copy it. And I'm going to highlight this, hold down Shift and press V to paste it. So I just copied and pasted. This says here, down underneath, the solutions, or this one solution depending, are the x values at the intersections of the three graphs. It's the x values. So there should be the intersection of three graphs. I don't see three graphs, so I want to zoom out. I'm going to zoom out until I see three graphs. I see green and purple right now. I do not see red. You see how I now see red? I'm going to pause this. I'm going to let you find out what is the intersection. You'll click that point to get your answer. Again, it's the x value you're looking for. All right, now I'm going to move on. I'll let you get your own answer there. I have one more bonus, I call it bonus question. Before we get started on the new stuff, from lesson 3.1, it says Greg invests $15,000 in Apple, earning 9.2% compounded exponentially. If Apple continues at this rate, how long will it take for the stock to be valued at $45,000? We had a calculator for this. Wasn't InSolve. Which calculator do we use for this problem? I hear number 9. That's right, compound. Anytime you're dealing with compound, you're going to use number 9. Open up number 9. I'm going to copy down these variables. We'll fill them in. What is our A? Represents the final amount. Did they give us a final amount on this problem?
Yes,
45,000. Good. Do not use the dollar sign. Do not use a comma. Just 45 followed by 3 zeros. Next is the P, the principal, the starting amount. It's 15,000. Again, do not use a dollar sign. No commas. 15 followed by 3 zeros. Next, rate. 9.2%. And to cancel the percent, we divide it by 100. We can type that in. Time. How long will it take? That's our x. We don't know. And again, for Desmos, the variable leave as x, just like last problem. The n, you don't always have n. Sometimes you'll use the formula with the e instead, which n means a certain number of times per year. Like if it said weekly, there's 52 weeks in a year, n would be 52. If it said daily, it'd be 365. If it said monthly, it'd be 12. E means it's happening all the time, and you don't even have to fill in the n. Or it stands for exponentially or continuously. How often is this problem compounded?
Exponentially.
Okay, exponentially, the E stands for E, so you're not going to use the N this time. But yes, exponentially also can mean continuously. So we're using the E. So when you come over here, it's 45, 3 zeros, 15 followed by 3 zeros, 9.2 divided by 100. T needs to be X. N, you can leave that blank. You can close it. Doesn't matter. We're not using N in this problem. What does matter is down here, we have to do an N solve. Right now, I have two different graphs based off of two different formulas. Which formula is the correct? The top formula or the bottom formula? The bottom, because it has the E. The top's not good. So you can uncheck the red, and that way you're only seeing the blue graph. Click that intersection for the answer. I'll give you a few seconds to do that on your own. So now let's take a look at the lesson 3.3. So what we're going to pick up with today is going to be applying properties of logarithms. There are 3 properties that are essential to know, okay? So here's what they are. This is on your packet. The first is a product property. So let me explain it to you this way. If you have one log and the inside is made up of factors, you could separate those factors out as to multiple logs. So let me say it a little more succinctly. One log multiplying is equal to multiple logs adding. And that's what that's trying to show you here. So they just use the letters X and Y. This could be more than 1 or 2 factors. This could be, let me do log B, let's do XYZ. XYZ, that would be equal to log B of X plus log B of Y plus log B of Z. So one log multiplying becomes multiple logs adding. That's rule 1 for product property. Okay. Second rule, it's called the quotient property. What would you guess is true of the quotient property? What about dividing? Quotient does mean divide.
Is it track?
One log dividing is going to be multiple logs with subtraction. So what happens if you have more than one factor? Let me show you. Rewrite this as log B. So the B means any base. Let's just say it was 4x divided by yz. What that would be equal to is anything in the numerator becomes a positive log. So log B of 4 plus log B of x. And then you would subtract anything in the denominator, minus log B of y minus log B of z. So one log dividing becomes multiple logs adding and subtracting. Numerators become addition, denominator becomes subtraction. Cool on that one? Finally, that last rule, the property, is the power property. If you have a power, it's equivalent to moving that power to the coefficient. And that math works just fine. I don't need to walk that through. Here, I'll do it on the problem, okay? We're going to do these 3 rules and we'll simplify. That's all we're doing today for the whole lesson. Simplifying and doing these 3 rules. All right, so what I'm going to do here is copy this so that in each problem, we can kind of see the rules as we go. Example 1 here says express log 96 in terms of log 2 and log 3. I'm going to paste the rules. And as I told you, we're going to do these 3 rules as well as simplify today. Now, simplify, you can do at any step, but typically product and quotient will happen together. One or the other will happen, and then power will happen separately. So I'm going to break these up into like 3 movements. We'll either do product or quotient, then we'll do power, then we'll simplify, or we might simplify first, then do these 2. So when I start this problem, what I'm going to do first is to simplify 96 into factors. So I'm going to use upside down division to prime factorization of 96. I'm going to use prime numbers and see what numbers can go into 96. This suggests using 2 and 3s. I'll start with the 2. Can 2 divide into 96? Yes, it can. Let me click, in case you don't know, I'll do a blank graph here. How many times can 2 go into 96? Do y'all know? 48. Okay, I don't even have to type it in. Great. 48. Last class, would we say we're done there or we keep going? Keep going. Okay, can 2 divide into 48? 24 times. Perfect. You keep going until we get prime numbers. 2 goes into 24 12 times. 2 goes into 12 6 times. And 2 goes into 6 3 times. Okay, here's the one difference from last class. Is today we're fine as long as it's a prime number. As long as it's prime. Last class, we only wanted 2s. This class, we're fine if it's prime. 3 is prime. We're good. Here's what we just established. 96 is equivalent to 2 times 2 times 2 times 2 times 2. 2 to the 5th power times 3 to the 1st power. So you can just leave it as a 3. So step 1, I'm going to call this simplify. We're going to say log of 96 equals log 2 to the 5th power times 3. Wait, what's you doing there? All right, so we just simplified. Oh, let me write down over here on the side, simplify. Let's go ahead and add that word simplify. Simplify. Okay, now that I've simplified, I'm going to ask you, what do you think? When you look at this, could we do product, quotient, or power? And specifically, if you're expanding, you'll do product or quotient first. And you will do, not necessarily, simplifying can happen anytime, but you'll do product or quotient first, and then secondly, you'll do powers. That's kind of the order here. So do I have a product or a quotient in this problem? Product, or is that a quotient? That's a product. So the rule for product is 1 log multiplying is equivalent to what? Okay, 1 log multiplying is equivalent to multiple logs adding. So where the multiplication is, I'm going to put addition, but it's not just 3 by itself. It needs to be log of 3. Like that. There's no base on this problem. What would be the base if it doesn't show one, but it says log 10? Yeah, it's a base of 10. Great. Okay, so now I just did the product property. So put product to the side there. Product property. Product property. Okay, now after you do the product property, you look to see, can I do the power property? Do we have any powers in this problem? Yeah, what's our power? The 5. What can I do with that 5? According to the power property, you can move it and make it become the coefficient. So our answer here will be 5 times the log of 2, or 5 log 2 plus log 3. That right there was the power property, and that is our solution. So log 96 is equal to all that. All right, so let's check this out again. You saw me do it once. Let me guide you through it twice. On this next problem, we have, it says express log 32 divided by 9 in terms of log 2 and 3. So I'm going to first paste our rules. So we have our rules. And let's think about this together. Last time I simplified first. Can we simplify the number 32? Yes, we can. What prime number can divide into 32? Can 2 divide into it? Yeah, it can. How many times does 2 go into 32? 16 times. Great. Can 2 divide into 16? Yes. How many times? 8. Can 2 divide into 8? Yes. How many times? Can 2 divide into 4? Yes. How many times? Twice. There it is. So 32 is equivalent to 2 to the, let's see, 1, 2, 3, 4, 5. 5 2, so 2 to the 5th. Great. And now let's also simplify 9. Can 2 divide into 9? Yes? 2 can divide into 9? No. What can divide into 9? 3. How many times can 3 divide into 9? 3 times. I'm done. So 9 is the same thing as 3 squared, because there's 2 of 3s. There's 2 3s, 3 squared. So the first step here is we will rewrite log, I'll call it simplifying, but we're going to rewrite log of 32 divided by 9 as log of 2 to the 5th power divided by 3 squared. And I will call that simplify. We could. The order on that wouldn't matter, but so I just stuck with the same order I did the first problem. All right, so now I'm examining my new log. And I notice it's 1 log with, what's that little line right there mean? Dividing. If you have 1 log dividing, that's equivalent to multiple logs subtracting. The numerator will be a positive log. The denominator will be a negative log. So let's rewrite this quotient rule. This is equivalent to log 2 to the 5th is in the numerator, so it'll be positive minus log 3 squared. It's a minus log 3 squared since the 3 squared was in the denominator. That right there is called the quotient property. Finally, what's the property we have not done yet? Power. We have powers here. So I'm going to take my powers, and where can I place my powers? And the coefficient. This is the power property. So our final answer, or said another way, log of 32 divided by 9 is equivalent to 5 times log of 2 minus 2 times log of 3. That's my solution. And I didn't show you on the first one, but you could type these in the calculator just to find out. So log of 32, I think I need to use a parentheses here, 32 divided by 9. And you can check it out. Is that equivalent to 5 log 2 minus 2 log 3? What do you think? Are they equivalent? Yeah, they're the exact same. So we did do it correctly. So, and we could check the first one as well, but those are matching up pretty good. All right, so now it's your turn. You've seen me do 2. Hopefully you took these notes well. Let's see if you can duplicate it and solve DOL number 1 here. This is not IN, this is an LN as in natural log. What's the base if it just says LN? It doesn't write the word log. It is a log, but what's the base? Nope, that's if it just says log. This just says LN. E, that's right. LN means that the base is E. LN means the base is E. It's called a natural log. All right. You go ahead and solve this problem. Do the same steps. Break down your 125 and 27 into prime factorization, and then apply your properties. Now let's take a look at example 2. Now example 2, honestly, could have belonged. Example 2 could have belonged to last lesson. The one thing that's a little different here that I want to point out is that when you're taking a third root of something. So as I was saying before the announcement, third root of anything means divide by the power of 3. So on this problem, we have the third root of 32. There's not a power on the 32. If it doesn't show a power, what's the power? 10. No, on the number 32. 1. So here's what that means. 32. The third root of 32 is the same thing as 32 to the power of 1/3. I'd recommend you write that down. The other thing I'd recommend you write down is a square root. A lot of us know a square root cancels a square, but we don't know why, and that's because it's dividing by the power of 2. So a square root would be equivalent to the power of 1/2. 1 divided by 2. X to the first divided by 2. And I want to make sure we totally are following what I'm saying. So I'm going to give you 2 more examples. What if we had the third root of x squared? The third root of x squared, what is that equivalent to? X to what power? 2 divided by 3. Or what about this? What if I gave you a group? What if I said the square root of x plus 1? X plus 1. What's that going to be equivalent to? Well, is the x plus 1 in the square root? Yes, so it's going to be the whole x plus 1 raised to what power? 1/2. Okay, I just wanted to give you some examples of how that works. So what I'm going to do first here is simplify by rewriting this. So log 2 of the third root of 32 is equivalent to log base 2, we already wrote it up here, 32 to the 1/3. And I'm just going to call that simplify. I know it's just rewriting. I'm going to call it simplify. I didn't paste my rules. Let me get that on there board. There's my rules. Okay, so step 1's been completed. All right, now, what do y'all think we could do secondly? Power. What can I do with that power? Move it to the coefficient. Very good. So we can move this to the coefficient. This is, you said it, power property. So it's 1/3 log 2 of 32. That is the power property. All right, last lesson, we did these logarithms by hand, and I told you we can type them in the calculator. What would you want me to do? Do you want me to solve this logarithm by hand, or do you want to just type it in the calculator for the solution? Hand first? Okay, a logarithm, remember, to solve a logarithm, you change it to exponential. So you would say 2 to what power? 2 to the x equals 32. 2 to the x equals 32. And we would do upside down division. But we already, you remember on a previous problem, we already found out what 2 or 32 is the same thing as. On example 1b, we found out 32 is 2 to the 5th. Y'all remember that? So I'm just going to write here 30. So 2 to the x is equal to 2 to the 5th. Since this is 1 to 1, they both have the common base. Our answer here is 5. So this is 1/3 times 5. 5/3 is your solution. Log base 2 of the third root of 32 equals 5/3. And this one we could have typed in the calculator because we had nothing more than numbers to begin with. So I'll just show you. We could have typed this in. Log shift minus is the base. I think you have to do this in parentheses. And I'm going to go Desmos calculator, functions, misc, and root 3 of 32. And it says 1.666. If you hit the little fraction button on the left, you can see that the answer is 5/3. So that is correct. We got 5/3. That is the right solution there. All right. Let's try another. That's how you type that in the calculator. Or you could type it in also. I should have put that 1 divided by 3 of log base 2 of 32. And you would see that's the same solution right there. So we did do it correctly. All right. Next one. What do y'all think? What can we do first here? I'm kind of opening it up from me do it to now you with me do it. What could we do first on the second problem?
Lay them out.
Do what now?
Lay them out.
What do you mean lay them out? Okay, I'm not following what you're saying. We could type it all in the calculator. Yes, we could. What's something I could do with these powers? What can you do with powers? Make them the coefficient. Well, we already have coefficients on them. So coefficients normally multiply. So this is just going to multiply. What is, let me write it out first. 3 ln e to the 4th minus 2 ln, meaning natural log, e squared. If we move those coefficients or move the powers to become coefficients, it becomes 3 times 4. What is 3 times 4? 12 natural log of e minus 2 times 2 is 4 natural log of e. That was the power property right there. Now, these are actually like terms. I have 12 natural logs of e. I have 4 natural logs of e. What's 12 minus 4 natural logs of e's? So 8 natural logs of e. That's just simplifying. Do you know what's the base of a natural log? It's a base of e. E to what power? Let me change this to a different color here. E to what power gives me e? 1. That's a natural log of 1. So this is just 8 times 1. What is 8 times 1? 8. That's our solution. So 3 times the natural log of e to the 4th minus 2 natural log e squared should be 8. And again, we just simplified. Could we type this in the calculator? You bet. Let's just try that real fast. 3 ln, that's not an in, that's a ln, e to the 4th power minus 2 ln natural log e squared. Says the answer is 8. And that's just because the natural log of e is 1. So we did do that correctly there. All right, with that, you now have your next problem. I'll let you try. I'm sorry, I have 2 more. I might come back to these later. For now, we can just type these in. We'll get solutions here. Log, how do you do that little base of 16? Shift minus 16 of 32 is 1.25. How do I turn that to a fraction? Click on that little fraction button on the left. And then we will also do, so this is going to be 5/4. You can put that equals 5/4 here. And I'll come back and do the work later. And then this next one, you cannot type in a base of 1 divided by 25. That doesn't work, as you can see. So if you were to do this one, what you would have to do is figure out what 1 divided by 25 is as a decimal. Once you know what it is as a decimal, you could find out this value is negative 1.5 or negative 3/2. So this one you can say negative equals negative 3/2. Okay, for the sake of time, I'm going to pass those 2 and I'm going to let you try this deal number 2. Now remind yourself, what is the 3rd root of 81 equivalent to? So you can make that substitution. What is that equivalent to? This is equivalent to 81 to what power? 1/3. Very good. And go from there. Deal number 2. All right, I'm going to go ahead and fill out C now. The way you would solve this is you would say 16 to some power equals 32. I'm solving this as exponential. And so I'll do upside down division. 16 divides into 32 2 times. But we have a problem because 16 and 2 do not match up. So I would need to do upside down division on the 16 as well to get to the prime number of 2. So I'll divide 16 by 2, which gives me 8. 2 divides into 8 4 times. 2 divides into 4 twice. What I just established is that 16 is equivalent to 2 to the 4th power. There's 4 2s. 32, if we don't remember from earlier, is 2 to the 5th power. This 2 and these 4 2s, 2 to the 5th power. So I have 2 to the 4th raised to the x equals 2 to the 5th power. Power to a power multiplies. So 2 to the 4x equals 2 to the 5th. Since I have a common base, you can cancel those 1-to-1 property. It says remove those. So 4x equals 5. And finally, you would divide by 4. Thus, you get the answer 5 divided by 4, like the calculator said. And D would work this way. We would start with 1/2 or 1/25 raised to some power. That's a fraction. I need to put that in parentheses. Equals 125. As a review from lesson 3.2, if you want to get rid of a fraction, you can make the power negative and it takes the reciprocal. So 25/1, which is equivalent to just 25, raised to the power of negative x equals 125. We would divide this upside down. 125 divided by 25. 25 goes into 125 5 times. We do not have a common base, so I would need to break down 25. And that is 5 goes into 25 5 times. So 25 equals 5 squared. And 125 is 5 cubed. So I now could substitute here. We have 5 squared raised to the negative x equals 5 cubed. Power to a power multiplies. So it'd be 5 to the negative 2x. Those multiply. 2 times negative x is negative 2x. And 5/3. Since I have a 1-to-1 common base, whoops, I could cancel these out. And negative 2x equals 3, which finally, when you divide by negative 2, we find out x equals a negative 3/2. That's how you got that answer. Example 3. All right, now we get to do some fun stuff. Now let's mix in some variables, things that we can't just type in the calculator to give us the answer. So I'm going to paste our rules here so we remember. And a little recommendation is to first, when you expand, this is for expansion, we're first going to try this property here. We'll try these two together first. Secondly, we'll try the power property. And the simplification can come at any time. Just want you to know that. You can simplify at any time. So when I look at this logarithm, I can't simplify right now because I have variables. You cannot simplify a logarithm with a variable. So I can't actually simplify right now. I'm going to go off this. Do I have a product in this logarithm? Is there a product? Is this logarithm multiplying? The 4 is multiplying. I agree. 4 is multiplying m cubed. Anything else multiplying? M and n are multiplying. So yes, we have a product here. Now we said it earlier. 1 log multiplying is equivalent to multiple logs adding. So here, write this out, that we have log base 2 of 4 m cubed n to the 5th. That's going to be equivalent to, we'll break this apart into 3 logarithms because there's 3 factors. Log base 2 of 4 plus log base 2 of m cubed plus log base 2 of n to the 5th power. That right there was the product property. Now, the reason I do product property first is if you tried to move your powers to the front, it would have thrown off these logarithms. You first have to expand it so they're separate, and now we can do the power property. What does the power property tell us about our powers? They become coefficients in front of their own individual logarithm. So this will have a 3 out front, and this will have a 5 out front in the coefficient. So this will be equal to log base 2 of 4 plus 3 log base 2 of m plus 5 log base 2 of n. What property was that? That was our power property. Which now we get to simplification. Can we simplify any of those logs? Do any of the logs, let me change the question. Do any of the logs not have a variable? Logs 1, 2, or 3? Log 1 does not have a variable. You can type this in the calculator. You go ahead and type that calculator. Tell me what that value equals. Log shift minus to get the base. Log shift minus of 2 to the 4. Tell me what that equals. Lyric's saying 2. Do y'all agree? Shift minus 2 to the 4. She says it's 2. I agree with her. So to simplify this, our final answer would look like this. Log base 2 of 4m cubed n to the 5th is equivalent to 2 plus, so that log right there became a 2, plus 3 log base 2 of m, cannot simplify, that's a variable, plus 5 log 2 of n. That's our solution right there. After simplifying. So that would be our solution. All right, let's check this out again. Example 3b. So example 3b, one thing that's different on your packets, at least this school year, is I've edited this problem. Put a y in your denominator. You see how mine has a y? Don't put it in the radical. Put it after the 4th root of x. Just put a y down in your denominator. If you have me in future school years, you won't have to worry about this if you want to take me a second time or something like that. But otherwise, just draw your little fraction line longer and put an x down there in the denominator. All right, let's go through and solve this one. Simplify. Can I simplify this logarithm right now? No, because I have variables. So you can't simplify. That's what you look for. If you don't have variables, you can type in the calculator and simplify. This I cannot simplify. So we got to go off our properties. Do you have a product or a quotient? We have a quotient. So we'll do that first, and then we'll do power second. So 1 log dividing is equivalent to multiple log subtracting. The numerator becomes positive. Now, I'm not just going to write this out as 2 total logs. How many factors are in the numerator? Can I break apart the 9 and x? Yes, the answer is yes. That becomes log base 3 of 9 plus log base 3 of x. Now in the denominator, I added that y so that you have 2 different factors in the denominator. Minus log base 3. I'm going to rewrite, what's the 4th root of x going to be equivalent to? X to the power of 1 divided by 4. All right, so x to the 1/4. And then that y is also in the denominator. So it'll be a negative log minus log 3 base 3 of y. That y was not underneath the radical. So it's not a power of 1/4. It's just a y. That step right there, what do we call that step I just did? Quotient. That was the quotient property. Okay, after you do the quotient, you look to see if you can do the power. Do I have any powers? What can I do with that power of 1/4? It becomes the coefficient. So we now have log 3 of 9 plus log base 3 of x minus 1/4 log base 3 x minus log base 3 of y. That right there was the power property. So after doing both those 2 steps, what do we now do? We can simplify. Do any of those logarithms simplify? The question you're going to ask yourself is, do any of the logarithms not have a variable that you can type in the calculator? Yeah, which one? Log base 3 of 9. That right there, what that really means is 3 to what power gives me 9? It should be a 2. Let's see. Whoops, what in the world? Okay, over here, if I change this, log base 3 of 9, the answer is 2 because 3 squared is 9. So that is a 2. So we have 2. Now the next simplification is a little bit trickier this time. This is the first you've seen this. This right here can simplify. I have a log base 3 of x and a negative 1/4 log base 3 of x. They're both log base 3s of x's. There's both of them. This is 1. I have 1 log base 3 of x and minus 1/4 of them. So what's 1 minus 1/4? Y'all agree with him? 1 minus 1/4 is 3/4. If you have a pizza and you lose a quarter of it, how much pizza is left? 3/4. Okay, so this will be plus 3/4 log base 3 of x minus that log base 3 of y. That right there is simplifying, and that would be our answer for this problem. All that log base 3 of 9x to the 4th root of x times y, which is a whole lot to write there, but that's the solution. All right, you've seen me do it now a couple times. Let's see, you follow the same steps and solve DOL number 3. Before we go too far, remind me, I showed you something earlier. This is a square root of x minus 7. What is that as a power? It's going to be the power 1/2. But this is x minus 7, so it'll be parentheses x minus 7 to the 1/2. Okay, so go from here and solve DOL number 3. All right, now it's time to flip the process. So what we've been doing today is expanding so far. Expand, expand, expand. This time what I'm going to do is give you something expanded, and we are going to condense it. So let me skip that. Let's take a look now at example 4. We're going to condense this logarithm. So here's our rules. And remember how I told you simplify can come at any step, but normally or earlier when you expand, you do product and quotient first, power second. Well, when you condense, you go opposite. So this time we're going to look to see, can I first create a power? And then secondly, can I turn it into a quotient or turn it into a product? So that's the order we're going to do this problem. When we go condense, we're going to go backwards. So on this one, first check, is there anything I can simplify by just typing in the calculator? Meaning there's no variable in the log. Is there any of these with a no log? I mean, no variable? No, can't do that. Okay, so can I change anything to become a power? What can I change to become a power? The coefficients. This 1/2 will become a power, and the 3, not the negative, leave the negative alone. The 3 becomes a power. So this will be equal to log base 4 of x to the 1/2 minus log base 4 x minus 2 cubed. That is the power property. Are you cool with what I did there? Coefficients became powers. That's all I did. Coefficients became powers. Now we'd ask ourselves, these two logarithms, they're subtracting. 2 logs subtracting is equivalent to 1 log dividing. So this will be equal to 1 log dividing. Log base 4. The numerator is the positive log, which is x to the 1/2. The denominator is the negative log, x minus 2 cubed. That right there was the, what do we call that, quotient property? Now, technically, we could simplify one thing in this problem. Does anybody see what we could simplify? X to the 1/2 is equivalent to x squared. So we could rewrite this if we wanted to as x, the square root of x divided by x minus 2 cubed. So again, 3 steps, nothing changed there. And that would be our solution. Let's take a look now at part B. Part B, I'll paste these rules again. All right, so whenever we go to condense, you're first going to check to see it. Well, I guess if you can simplify, great. But if not, you'll do power. And then after you do power, you'll either do product or quotient. So on this one, are there any logarithms I could just type in my calculator to simplify? Oh, and by the way, this is log with the base of e. That's the natural log. Log with the base of e is natural log. All right, so if there's no simplification yet, I need to check for a power property. Could I create any powers by coefficients? Yes. What's the power of 5? All right, excuse me. The coefficient of 5 becomes a power of 5, and the coefficient of 6 becomes a power of 6. So this is equivalent to the natural log of x plus 1 to the 5th power plus the natural log of x to the 6th power. That is the power property. That's great. So we first did the power property. Now you'd ask yourself, 2 logs adding. 2 logs adding is equivalent to 1 log multiplying. 1 log multiplying. So this becomes 1 natural log. And we multiply. Since I'm multiplying, typically we put the, if x is by itself without a transformation first. So I'm actually going to put x to the 6th first times x plus 1 to the 5th. I'll rewrite the order just because that's the way we normally write it. Would be x to the 6th first. That is the product property. Is there anything I can simplify or change here? I don't think so. I think that's our solution. So no simplification this time, but I did just put the x to the 6th first just because that x was isolated without a transformation. All right, your turn. I want you to try this one. Now remember, don't change anything with the plus and minus. Just look for your coefficients and so forth, okay? This problem also, your packet, I switched a little bit. Scratch out the front and minus 2 ln x. Okay, a little heads up here on this, a little tip. Something might cancel, okay? So just be aware of that. Something may cancel. All right, now we're going to talk about the change of base formula. Now, I don't exactly use this the way the textbook describes just because with technology we don't have to, but this statement here is true. And just to kind of give you an example of what it's talking about, it's just saying that if you had, say, log, let's just say it was base 7 of 5, you could actually solve this by taking just the common log of your 5 divided by the common log of 7. Or if you wanted to, you could say this would be like the natural log of 5 divided by the natural log of 7. Any of these are the same. That's just the change of base formula. And so when we get to example 5, I want you to know you could just type this into the calculator to get your answer, which I will do this real quick just to show you. Log base 6, that's how I did shift minus 4 plus log base 6 shift minus 54 plus log shift minus 6 of 6 plus log base 8 of 1. And the answer is going to be 4. Now, how I can do this quickly is trying to explain it this way, since you now know what the answer is. The answer is going to be 4. Is you could just look at this and say, okay, this is 6 to some power equals 6. I know this value has to be 1. And 8 to some power equals 1. That unknown power here has to be 0. So I could, and these two have a common base, and they're adding. 2 logs adding is the same as multiplication according to my properties. And so doing a couple things here, I could rewrite this as saying this is equal to log 6 of 4 times 54. And then that's right here, that portion. And then plus 1, because that right there is 1. Okay, so I simplified there. And over here, I did the product property. property. There you go. And so now you would be solving this. So 4 times 54, I believe is 216. 54, 216. Yeah. So really what I'm looking for is if I rewrote this, that is log, oops, got the O, log base 6 of 216 plus 1. And that plus 1 is not involved in that log. So I guess I can make that clearer by adding a little parenthesis here. And let's make the parenthesis here so we can see that that is not a part of that logarithm. And so you just be asking yourself, how many times can 6 go into 216? 6 goes into 21 3 times with the remainder of 3. So the little remainder of 3 I'll put up here. So 6 goes into 36 6 times. I'm not done because 36 is not prime. So 6 goes into 36 6 times. Now I have the same base. I know it's not prime, but that's 6 cubed. So 216 must equal 6 cubed. And so I could rewrite this now as log base 6 of 6 cubed plus 1. And again, after I do the power property here, we do the power property, we have 3 times log 6 base 6 of 6 plus 1. That right there to get to that form is the power property. That's supposed to be a P property. There we go. And from the power property, log base 6 of 6, 6 to the first power. So it's 3 times, that's a 1. 3 times 1 is 3 plus 1, that's how we get 4. So all that would equal 4. All right. So again, you can type all that in a calculator, which I'm no fool. That's what I'd expect most students to do. And you can get an answer in that form right there. Let me shrink this just a little bit so you can see the rules plus that value. Okay. And we have a part B. Again, I could not combine these two because the bases are different, but you could simplify if you wanted to say, okay, half, that's a base of 1/2 to some power equals 8. Really what I'm doing is I'm converting this log to exponential. And to solve that, I'm going to first get a base of 2. I don't like working with the fractions, so I'm going to take the reciprocal, and technically I need to have a parenthesis there. And so I'm going to take the reciprocal, and so it's going to be 2 to the power of negative x equals 8. So a negative power takes the reciprocal, and 2 over 1 is the same thing as just 2. So there we go. And so upside down division, 8 divided by 2 is 4. I don't stop because 4 is in the base of 2. It's not prime. And 2 goes into 4 twice. So 8 is equivalent to 2 cubed. So now I know 2 minus x, or excuse me, 2 to the power of negative x is equal to 2 cubed. I have a common base. So 1-to-1 property. 1-to-1 property tells me that this is negative x equals 3. And if negative x equals 3, then positive x, I divide by -1. If negative x equals 3, then positive x equals -3. So that's the value there. So I would have a -3. So what we just found out there, that is equal to -3. Or I could come back and say it this way. Let me rewrite this. Log 1/2 of 8 is going to be replaced by -3 minus log base 3 of 1/9. Make that more like an 8. Okay. And so if I did the same thing for 3 to the power of x equals 1/9. Whoops, put 1/3. 1/9. Here, 3 to the power of x equals 1/9. That's the same thing as 3 to the negative x equals 9. You take the reciprocal. And we know 9, I'm hopeful that you know that 9 is the same thing as 3 squared. That equals 3 squared. And so here I would have 3 to the negative x equals 3 squared. And so 1-to-1 property says I can simplify that out of there. Negative x equals positive 2. So if negative x equals positive 2, then positive x would equal a -2. So when I come back over here, we have -3 minus a -2. -3 minus a -2 is -3 plus 2, which is going to equal -1. And that would be our answer this time around, -1. So we can type this in the calculator. log, it won't let me type in 1/2 here on the base, so just do 0.5, that's 1/2. The 8, -3, perfect, minus log base 3 of 1/9. I need to do this in parentheses, 1 divided by 9. Notice the answer is -1. So we did it correctly. And we didn't have to use those properties this time around. We just got the solution straight up from it. Now it's your turn. DOL number 5, you use calculator or you can use algebra. All right, let's conclude this lesson with a word problem. How might this be used in the real world? Well, it says in ecology, a diversity of a certain ecological environment containing 2 different species is modeled by this function here, where N1 and N2 are the numbers of each type of species. So N1 and N2 are the numbers of each type of species found in the sample. S equals N1 plus N2. So there's a formula for us. Find the measure of diversity for the environments that find 25 and 50 species in the sample. So if 25 and 50 are the species, S is the sample, N1 and N2 are the types of species, I'm just going to say N1 is 25, N1 equals 25, and N2 would equal 50, which means S here would equal 25 plus 50. I don't need that in parentheses. I can just say 25 plus 50. So it says find the measure of diversity, which means we're finding the D. Find the measure of diversity. Find the measure of diversity, which is D. So we're trying to find D right there. So what I'll do is I'll just type in this formula straight up in, and let's see what the calculator says. D equals negative, and I'll type it in just how it looks. So parentheses N1 divided by S log base 2. And here N1, I need to do a shift divide to make that division over S plus N2. So I just did a capital N followed by 2. It automatically does subscript divided by S times the log base 2 of, again, capital N with a 2. I will highlight, holding down shift, highlight it, and then press division and makes it dividing over S. Now my equation looks the same. I'm just going to hit add slider. The S was given as N1 plus N2. Honestly, you could put parentheses around it like they had it, but that shouldn't change the problem. And now our values were 25 and 50. That right there would be my diversity rating. So I'm going to go ahead and add these in the notes so you can see them. That would be the values. So our solution here, our diversity, if I'm going to round to the nearest 100th, the diversity is approximately 0.92. Now let's check out part B here. Now part B says find the measure of diversity for the environments that find 10 and 60 species. So now we've changed our N1 and N2. So now we're going to say N1 is 10. I think I did that red before, so let me stick with red. N1 is going to equal 10, and now N2 is going to equal 60. And I'm glad I typed it in this way because I don't have to change all this. All I have to do is change N1 to 10 and N2 to 60. I do that, I get my new diversity. And so you'll see that this diversity is a lower percentage, and that makes sense. If you think about it as far as ethnicities go, let's say you're in a classroom and you have 2 ethnicities. Let's just say it's Latino and African American. If you had Latino and African American, and in the first scenario you have 25 Latino, 50 African American, and in the second scenario you have 10 Latino, 60 African American. Well, obviously the first one had more diversity, meaning a closer average across the 2. The second is less diverse, and that's why the number is lower. So that's just a little description of what it's actually finding here. And the diversity here would be 0. I'll do it to 2 decimals, 59. So that's example 6. With that, you have a DOL. Go ahead and see how long, or to solve this problem, what the exposure, or how many stops would a photographer use to get the 1/4 exposure. All right, let's finally finish this lesson off with an ACP review question. It says Matthew and some friends are going to a concert. They hire a car service for $75 to drive them to a restaurant for dinner and then to a concert. They divide the $60 cost of dinner equally. However, since Matthew's dad provided concert tickets for the group, the friends agreed that Matthew doesn't have to help pay for the car service. The friends divide this cost equally among themselves. If each friend spends a total of $25, how many friends went to the concert with Matthew? So the idea on this problem, it comes from that old, I don't know, it's 6th grade, that an average cost or an average of any type will equal the total of whatever was calculated divided by the number, or the number of people, the number of, if you're taking the average grade, be like your total amount of points that you've earned divided by the number of assignments, something like that. That's the idea on this problem. So the thing we are looking for are friends. It says how many friends? So that's going to be X. That's what we're looking for. So to write an equation, I'm going to focus on the money first. It says they hire a car service. I'll do this one first in green. Hire a car service for $75. So 75, they don't each pay 75. That's the total. So I'm going to take 75 and say that's got to be divided by something. And I'm going to continue on. It says they hire a car service to drive them from the restaurant for dinner and then to a concert. They divide the $60 cost for the dinner equally. Okay, so we now have another cost of 60. So this 60 here, I'm going to underline the $60 cost of dinner says is divided equally. And then this next line, however, since Matthew's dad provided a concert ticket, let me write this up here. We have a $60 cost, and that 60 is not each person. Each person's not paying 60 for dinner. It's divided equally. So that's a total as well, and divided by some number of people. However, since Matthew's dad provided concert tickets for the group, the friends agree that Matthew doesn't have to help pay for the car service. So here's car service, that's green. Matthew does not have to help pay for the car service. So question becomes, who does pay for car service? Answer, only the friends, which is X. Now the dinner, it says they divided the $60 cost of dinner equally, which means Matthew pays for the dinner as well. So Matthew's one person. So I'm going to put this, it's going to be friends plus Matthew pay for dinner. Now finally, if each friend spends a total of $25, so they all together on average spent 25 bucks. That goes on its own. And so these costs would be added together to give us an average of 25. If we solve this, we should get our answer. We could use the insolve calculator. So let me close that one off. I'm going to go to insolve, and we can solve this to get our solution here. We have 25 equals 75 divided by X plus 60 divided by X plus 1. Secondly, after you type in the whole equation, we'll do the Y equals the left, 25. And finally, Y equals the right side of the equal sign. The intersections of the three graphs should be a solution. I'm going to go off of that one there. The real world, you can't have negatives. That's not relevant. So this is going to be my solution. My solution is 5. We'd have 5 friends here. That would be our solution.